Today, I want us to look at a very important topic in the field of chemistry. Our topic for discussion is the mole. At the end of today's lesson, each one of us here will understand the concept of the mole and how it relates to atoms, molecules, and mass. I want you to take this topic very serious because you will apply the knowledge you gain today in your next topics. It is very, very important. So please, make sure you get the concept as we move on. Let's go into the lesson. Have you ever heard the word pair? We have a pair of gloves. We have a pair of footwear. A pair represents two items. We have a dozen, which represents 12 pieces of items. We have a dozen of handkerchiefs, a dozen of socks. We also have a crate of egg. Normally, a crate contains 30 pieces of egg. Have you ever tried to count the number of grains in a bag of rice or the number of sugar in a cup of rice? That is a very tedious way to do. So normally, such items are measured using the weight, that is in kilograms. In some part of the world, they use the measuring cup for that. So, items which are so many in number that it becomes practically impossible to count, we use a unit. And in chemistry, the unit used for counting particles in chemistry is mole. The particles refers to atoms, molecules, ions, and electrons. So, just as one dozen contains 12 pieces, one crate of egg contains 30 pieces of egg, one mole of a substance contains 6.022 times 10 exponent 23 particles. There is a scientist behind this study. The name of the scientist is Avogadro. So this mole is also called Avogadro's number. And Avogadro's number is 6.02 times 10 exponent 23 particles. There is a relation which can help us to work between the number of particles, mole, and the Avogadro's number. And the relation is n equals n times L. Let's solve this question. How many eggs are in two crates? We know that one crate contains 30 eggs. Therefore, two crates will be 2 times 30, which will be 60 eggs. Our next question is, how many atoms are in 2 moles of sodium? We also know that 1 mole contains 6.022 times 10 exponent 23 particles. Then, 2 moles will contain 2 times the Avogadro's number. And we are going to get 1.204 times 10 exponent 23 atoms. Let's pick a measuring cup of the same size and measure the same quantity of rice, sugar, and beans. It will be realized that when they are put on a weighing scale, even though they contain the same number of particles, the quantity is the same, the weight of them will differ. It means that every substance has its own weight. The same thing applies to the elements and the atoms. Each of them has its own weight. So, 1 mole of a substance, if you pick 1 mole and weigh, we call that molar mass. So molar mass refers to the mass of 1 mole of a substance. Let's see this. We have carbon's atomic mass equals 12 grams per mole, meaning 1 mole of carbon weighs 12 grams. Oxygen atomic mass equals 16 grams per mole. So 1 mole of oxygen weighs 16 grams. In the same way, when we pick hydrogen, 1 mole of hydrogen has its own weight. 1 mole of nitrogen has its own weight. And it has been experimentally determined. We have a relation which is mole equals mass over molar mass. And in our next lesson, we are going to see how we can use this equation to solve questions relating to moles, mass, and molar mass. For today, we have learned that the mole helps chemists count atoms, molecules, and convert between mass and number of particles. I told you to take topic very serious because it is essential for chemical reactions, titration, stoichiometry, and other aspects in chemistry. If you have any question, you can ask. I will end here and we will continue the next time when we have chemistry. Thank you for attending today's classes. Thank you.